So we continue with the communication technologies for IoT. And in this lecture, we'll be covering the wireless network technologies. So the last lecture was all about the infrastructure protocols and how we were working with which was basically about communication between IoT devices. This too is for the same purpose. But here we are going to talk about how mobile technology plays a role if you would like to communicate or send some data from one IoT device to the other. So basically this lecture would be all about how mobile technology is in use. Okay, so for that, let's begin with a term called M2M. Okay, this was a term which was there in the industry before IoT came in the picture, and majority of the services that we do or have been using in IoT are referred to also as M2M services. What are they? Now, M2M, as the name implies, refers to machine-to-machine interaction. So it's nothing but a network of machines. So it's a network, but it's a network of machines and whose purpose is for remote monitoring, control, and data exchange. So you connect different devices, different machines, basically for monitoring purpose. So one would be communicating its state to the other. One may be the controller, the other may be a slave. So the controller would like to know, okay, give me information about your state so that I will be able to know whether you're working correctly or not. So all this is what happens in case of the machine-to-machine interaction. Okay, so as you see, the service is basically focused towards remote collection, okay, remote collection and transfer of data from embedded sensors that are fixed or mobile. Okay, so you have smart mobile devices which are used to interact using various M2M technologies. So what basically is M2M? It's a network that comprises of machines which have embedded hardware, okay, for sensing, actuation, and communication. This is the basic idea. So you connect machines, as you see in this network. Here we have the devices, the machines, which are connected, and they form their local network, which we call the M2M area network. Okay, so this is the M2M network, and here is the internet, the core network, which connects to the different applications. Now these applications will be running on some cloud or some resourceful infrastructure. So there is one network that connects those machine network, which is a low range or low power network, to the resourceful network. So either it can be direct, the applications will be accessed directly from this lower network, or it can be via something called gateway, right? So majority of the times we require gateway. This gateway is the one that actually acts as a bridge between the M2M network and the IP-based network. The M2M network, as you see here, mainly uses these common protocols like Zigbee, Bluetooth, 6LoWPAN. These are the most popular networks that are used for communication among the machines. But the moment it wants to communicate to an IP-based network, there is something different from the local network, then it needs help of something called the gateway. And the M2M area network is a very small network. It has to take help of some services which are hosted on the internet. So it has to take help of the gateway. So what the gateway does is basically it acts, as I told you, it acts as a bridge between the device network and the internet. And the internet has IP-based protocol. The M2M area network uses proprietary protocols such as Zigbee, BLE. So there has to be a translation, right? So as you see here, this is the one that does this protocol translation. Okay, so it takes from the M2M node, does this protocol translation, and then sends it to the internet, which uses the IP stack, the proper IP route. Okay, so this is mainly the functionality of a gateway. So if you compare M2M versus IoT, you will find that so far we have been talking about similar things in IoT, right? So you may ask the question, where is the difference then? The difference is here. M2M is more of point-to-point connectivity, right? It happens mainly at the customer side, whereas IoT, it allows both remote and local devices. It's not that you have to have the devices only at a certain region and they are local. It's not like that. In M2M, all the devices are normally at one place. Say, for example, in factory or at home, you have all the devices which are nearer, they connect and they create a personal area network kind of. Okay. But in case of IoT, that's not the case. The devices themselves can be at one place, such as M2M, or they can be at different places. Even then, they can be connected. Okay. Then we have many devices that connect networks via cellulars or cable connection. Yeah, so this is important. They either can use of mobile technology, cellular connection, or cable connection to connect the devices. In IoT, the connectivity is basically a cloud-based. You have a third-party infrastructure. The devices get connected to that, and via that cloud, you can connect to other devices or to an application. This is the mechanism of IoT. In M2M, it's normally used for small scale projects. As I told you, for a factory automation, lining, etc. for this. But in IoT, it can be for a very large project, or weather station, or forest fire detection. That involves a huge geographical area and a lot of things involved in that. So it can be a large project. M2M devices do not always need to be connected to the internet. Yes, because if you really don't need to send something to the IP-based network or some services from the IP-based network, there is no need for connecting to the internet. Okay, but in case of IoT, devices really need internet access because the cloud services are actually obtained through internet. So you cannot have IoT without internet. Okay, so if you are handling a small device network without internet, you are actually calling it, or you should call it, a machine to machine interaction. But the moment there is internet involved in that, and all throughout, it is IoT. Finally, we have the devices which must adhere to same communication protocol. That is usually the case in case of M2M. All the devices are homogeneous. If you're talking about, let's say, a factory environment where there are 4 to 5 robots which are going to communicate, usually in the assembly line, the robots that you're going to use will be all of the same type. Because all the devices that are communicating, as you see in this picture, all the devices are basically homogeneous. So if they are homogeneous, it's obvious that the protocol, the communication methodology that they are going to use will be of the same type. But in case of IoT, the devices are heterogeneous. Just think about forest fire detection. You're using a temperature sensor, humidity sensor, and whatnot. So the different devices, they're absolutely heterogeneous system. And when you are taking an off-the-shelf component from the market, you are not dictating their communication technology. The vendor who's provided that particular mode or node has decided to use a particular communication technology. So obviously, the moment the devices are heterogeneous, the communication technologies are heterogeneous. So handling that is a real challenge. Comparatively, handling a problem in case of M2M is easy because the devices are homogeneous. So they use same kind of communication protocols. But that's not the case in case of IoT. Okay, so you have a lot of integration to be done in IoT, and that's a real challenge, right? Okay, So how can we make use of mobile to provide that? Well, so what happens is, this is the business model that you can see. It's like this, that the mobile operator would provide the IP based services, and we have an M2M partner. So here we have the customers, right? The customers would actually be communicating or would be requesting for some services through their M2M devices. But the M2M device will only be communicating to the customers, will be providing the services, but for the connectivity purpose, it is going to use some mobile operator. So the mobile operator will be providing the connectivity, and then the services will be provided to the M2M partner, and which in turn would send it to the customer. So normally what happens is, in case of a usual mobile operator, if you have a, let's say, a mobile operator, what you do as a customer is, so here is a customer, you put your request, okay, and this is the request of service you put, and all services by the mobile operator. Okay, so this is like we have what you can say, some business to customer, okay, some kind of a business model where you request for service and all payment etc. is done by that operator. It provides you the service on the payment basis, so the bills etc. will be generated by the mobile operator. But here you have it here, operator, okay, and the mobile operator is only providing you the connectivity, and here is the M2M network or the M2M service provider. Okay, so the customer will be requesting for the service via this M2M service provider. M2M service provider is actually making use of some mobile operator. It is getting this information from provider and providing it to the customer. So here is a business to business model as well, in addition to business to customer. So this is business to customer, and this is business to business, because mobile operator is also earning something from the M2M partner, and the M2M partner is also earning something from the customer. So look at this, how the invoice is generated. This is requested for this, so the invoice is generated by the mobile operator to the M2M partner, which in turn sends it to the customer. So here we have this, very interesting thing that can be utilized if you are using mobile technology for IoT purpose. So what is it if you are using mobile devices for IoT? This is the basic architecture. And what you see here is very, very similar to the usual protocol, IoT protocol stack. You have data which is collected from different sources. It can be an M2M data, that is a machine data, a data from other network devices, from sensors, etc. Or it can be data collected from the mobile, right? So data is gathered, and this entire data is by using some connectivity or some network technology, you send it to the cloud, where some data management is done, that is some database is maintained, and some analytics is performed. And depending on the analytics that you do, you you do some informed decision making, which is used by different applications, whether it is for transport, for energy, for smart buildings, for health purpose. So this is overall the picture that we have, right? Now, apart from that, you see, if you're using mobile, you need to have some kind of service delivery, right? Because you need some kind of services, and the services will be spanning across different applications. Now here you have to keep in mind that the services that will be provided will be requiring, different kind of services will be required for different applications. Now suppose you will be doing that through different APIs, right? So for every service, you have a specific API. You request the service through that API, and that is provided to the to the customer or to the M2M partner. Now, so the service delivery means there should be some kind of a developers who would be developing APIs for such service delivery. Okay. And the good thing is, so this enabling services is through these APIs. So I should. So there are service which will be registered, and there will be some services which will be provided through APIs. So the access will be through these. The use of mobiles will actually be, if you start using mobile technology in IoT, or if you are going to use mobiles for IoT, it will actually increase the demand of the mobiles further. And the good thing is they can be used for different purposes. Let's say for surveillance, for public safety, right? So public safety, then we can have something for surveillance. And in each one of them, you see the requirement will be different. If you are going for, let's say, some public safety kind of a thing, you may not be requiring, you may require a low bandwidth mobile network. Whereas if you're going for a surveillance, you will be requiring high bandwidth mobile network, because the data with which you are working will be a real-time data if you're going for surveillance, because we have a lot of images and a lot of things to processing to be done. So your bandwidth should be very high. Whereas if you are going for some public safety kind of an application, you may not require so high bandwidth. So if you are planning to use a mobile device as an IoT device, you should be aware of what are the constraints, for which purpose am I going to use it. And accordingly, you have to choose whether the mobile device is suitable for that or not. Okay, just by using a mobile as an IoT device, you may end up into trouble if you're not aware of the requirements of your system. Okay. So what is the requirement then if you are planning to use a mobile technology? First is that you have to support whatever mobile network you're planning to use. If you plan that, okay, I will be using the mobile network for the device connectivities. First of all, it should allow massive number of devices. That should be clear, because your devices will keep on increasing. If it is not scalable, then it may not be a good networking technology, right? You have to allow 100 times more. There should be a capacity. And okay, I will allow these many devices to be connected or will be using my network. Then it should support high data rate. Very, very important. The latency should be reduced as much as possible, because the performance will be hampered if you do not reduce latency. Then it should provide consistent quality of experience. It should not have packet drop or poor network. If you are using mobile for your IoT design, some IoT system you want to build, and you are going to use mobile for connectivity, well, you have to ensure that the mobile network is absolutely fine, or else your data, there will be huge data loss. So it should provide consistent quality, and it should not add to the cost of the system. You should not use a very costly mobile or a very costly network so that your entire cost of building the IoT system is spent on the mobile itself. If that is the case, then it is not a good solution. Okay, so you should think, should I really require to use the mobile? Then comes, okay, so the problem of latency and high data rate is solved the moment you jump into 5G networks. Yet to come. But okay, this may solve these two. Massive number of devices, well, if the bandwidth is high, many devices can be accommodated, no problem. But there is something, there's a different problem than that. And these two problems is what we are going to talk about. Please be very, very attentive, because these are the two technologies that I'm going to talk about are very, very important with respect to IoT. They are not only for mobile technology, but in general, whenever you talk about any networking concepts for IoT, you actually have to talk about these, and they have become one of the most key things for IoT networks. The first is called software defined networking. You may have heard of this term. It's called SDN IoT, very, very common. You may have come across SDN switches. What are these? What is it? Look at the term software defined networking. It means the networking will be controlled through software. This is the basic idea. What do you mean by that? The definition here says that it's a kind of network where you separate the control plane and the data plane. Well, what is this control and data plane? The control plane is the one which is which will decide how the data will move within the network, right? This will decide how the data will move. Basically, the protocols, etc., how the controller. And data plane is actually the devices, the network devices, the switches, etc. So the idea is that you have to keep these two separate. Well, what is the problem now? The problem today is this. If you look at the evolution, you will find that applications have evolved. The internet applications have hugely evolved. We have social media sites, video hosting websites, YouTube, Facebook, whatever. Applications have been innovation. There have been innovation in the technologies. We have moved from simple machines to servers to data centers and whatnot. But the protocol, they are where they used to be 10 years ago. It has become stagnant. What do I mean by that? I mean, if you look at the traditional computer network, you can divide that entire networking part into mainly three components. One that handles the configuration, the other that handles the algorithms, and the third that handles the transmission of data. The first, which is called the control plane, it's all about the algorithm that decides how the packets will be forwarded. Okay, like creating the routing tables, etc. So the algorithm behind transmission of the data. The second is the data plane, which involves the how packets should be forwarded. Okay, yeah, how here the packets are forwarded, here it should be forwarded. That's, we talk about access control, traffic monitoring. So it's all about packet streaming. Okay, this actually involves the different network devices, the different kind of switches you are going to use, these. Now, and the third is the configuration. That is the management, which collects, measures, and configures. This is the traditional computer network. And the problem is that all three are at the same place. Okay, all three are the same place. You are restricted by the algorithms and the techniques that are provided by your vendor who has provided you the switch. This is the problem, that you have a proprietary software and vendor specific configuration interface. Tomorrow, if you want to make some changes, you cannot, because it's vendor specific. This is the problem. You have a closed equipment. The software is bundled with hardware. You have very less innovations to do. Over specified. Sometimes there are a lot of specifications which I don't want. Few people who can innovate. It is very expensive. And if there is a bug in the software, you can't do anything. This is the problem. So the solution is, can we separate these two? Yes. So what we do is, we separate out the networking part and the control part. Look at this. So we have a control layer, okay, where so in between there's a controller, and this is the one that actually takes care of everything. We have an application there that learns the network applications, and the controller will be the ones where all your configuration, etc., will be done, and the switches will actually receive those information and logic, which is a software that will configure it. Let's see how. There are quite a few advantages of using SDN. First of all, the basic advantage is virtualization. That is the network resource. You don't have to know where that resource is. You can create you know, a virtual entity of that, and you can work on that. Kind of an abstraction. You don't actually need to know the switch. You are going to write a program considering that there is an equivalent switch for this particular entity, and that's the abstraction of that particular switch. And most importantly, so all equipments, okay, they are using the same program. That's the best part of that orchestration. You have all the components, they are controlled by the same device, which is the controller. And because the controller is sending out same kind of commands, they are all controlled by the same command. Next, they are programmable. You can change their behavior on the fly. So you don't have to just rely on the vendor specific configuration. You can change them dynamically. You can able to change the size, the quantity. Yes, because it's software control. So you have more flexibility. Okay. You reduce manual involvement. You can change the policy, the troubleshooting, etc. So this is basically the idea behind. Okay, so you increase visibility. You can look at how one device, network device, is working. You can optimize its utilization, and you can balance the load if you require. So this is the idea behind, or the benefits of using an SDN. So there are two components to SDN. One is called the controller that manages the flow control, and it enables intelligent networking. And just have a look at that. So there are two interfaces. Let me show you here. Yeah. So here you see the controller. It talks to the upper layers, which is called the northbound API. There are some APIs for communicating to upper layers. That is applications. So applications, if it is going to take help of some networking, okay, will talk to the switch, but not directly. It will actually talk to the controller. The controller will communicate. I mean, the particular application layer will communicate to the controller via an API. And the controller will talk to the lower layers again through another API. And this API is what we call the open flow protocol. So this is the protocol for controlling the behavior of the Ethernet switch. So I'll quickly give you the idea. So the controller talks to the application via the northbound API, and it talks to the networking devices via an open flow protocol. Okay, so this is the idea behind having an SDN. See how the configuration happens here. The applications are in this part, and the configuration now. Okay, so the open flow protocol is like this. This is a typical view of your open flow switch. So this is the view. So what happens is, when packets arrive, right? So let's say there's a packet arrives, the switch, the controller, it matches the, it's a packet coming from the controller to the switch. When the packet arrives, the switch matches the header, and then it maintains that in the flow table. So this, you see, this is a table that is maintained in every switch. Now, if the entry matches, whatever the corresponding action is to be taken, it does that. So, but if it does not match, that means the switch is unaware of that particular packet. The switch then puts a request to the controller saying that, okay, send it to, please do something, and the packet and the controller handles the problem. Okay. So this is the typical way in which things work. Okay. So the routing information is maintained in the switch. Packets are transferred to the switches, and the switches accordingly trigger or action whatever is required. This is the view of the Zodiac FX SDN switch that supports open flow protocol. Okay, so if your switch is an SDN switch, it must support open flow and able to do information within them, and they will be able to uh, the packets coming from the SDN controller. Okay, the second technology that is associated with mobiles, which is important, is virtualization. Now, you know about virtualization. We have an idea about virtual machines, right? If you recall, why do we use virtual machines? We want to run 2 or more different operating systems on the same machine. What is the idea? You have a hardware that has to be shared among 2 different operating systems. So you create a view such that every operating system is believing that the entire hardware is used by the same, used by only itself. That's the idea behind virtualization. So same thing here. The only idea is that here the network has to be visualized. So the network functionality, you create a virtualization of that. Okay. And because there are a lot of heterogeneous network devices involved, switches, servers, storage. So you create a virtualization so that you can consolidate heterogeneous network devices on the standard servers. And remember, virtualization is only used, the basic aim is to share things so that everyone feels that the entire thing is being used by itself. Example are virtual firewalls, load balancers, WAN accelerators. Okay. In fact, NVNFB is it's not necessary that you have to use NFV with SDN. The normal virtualization procedures are good enough to support that. But many of times what happens is you may not have, the things are, majority of the time, the resources that we are using are, they are customized and they are resource constrained. So it's better to use SDN for the networking part. So what we have is, as you see, the virtualized network function. It's a software implementation which is capable of running on the NFV infrastructure. And these are the key elements, the NFV infrastructure that includes the computer, network, storage, all virtualized, by the way, right? So you create virtual entities of each one of them. So all the applications that are going to run will believe that everyone has its one, it is provided one instance of the entire network. Okay, so when you are going for a 5G architecture, the problem is that you want to have minimum propagation loss and limited coverage. Okay, and so what we usually do is you have small cells you create, because it's a cellular network. So you take small cells and you put that on a large cell. So the small cells will be working on low frequency and large cells will be operating at high frequency. Okay, but switching between these low frequency and high frequency also is a very difficult task. So that is the reason why there is a need for separating out the control plane and the user plane, very similar to how we do in case of SDN. And that is the reason why I said that there is a need for SDN and NFV in mobile technology if you are going to use it for IoT, because not all the cells will be working at the same frequency. There will be smaller cellular network which will be working at low frequency. There will be higher cellular network which will be working at high frequency. But you have to, if your application constantly switches between these two, it's not possible. So you clearly have to separate out the control plane and the user plane, where the C plane will be working at low frequency bands and the user plane will be working at high frequency bands. And by this separating them out, you'll be able to improve the efficiency of the 5G architecture. There are quite a few features of 5G that should be kept in mind if you're going to use it for IoT. It should have two logical layers. It should support dynamic deployment of scaling network using SDN and NFV. You should allow virtualization. You should allow separating it of control and network part. And you should remove redundancies at best. Then there's a problem with, there's a genuine problem of energy when you are going to use IoT devices. And one of the research area focused towards handling this problem is energy harvesting, which says, how can you generate power from the device itself? So as you know that if a particular device is kept on for some point of time, it quickly drains out. And power source is a major issue. So one of the research areas is energy harvesting, which is like you want to do something, some power generating elements. Okay, so there will be some power generating elements that will be able to generate power from some devices, like you have some solar cells, okay, some piezoelectric things as you see here. So from the environment itself, so this is the energy harvesting device. It collects some energy from the physical world, and by using some power generation technique, you will be able to generate some power and feed it to your sensor network. Okay, so that the power source is constantly being supplied. But it's not so easy, because the power generation and the power feeding, it should be compatible. And more so, you should be able to know how much of a power can I generate and how much of a power will this be consuming. So there should be a proper power model computing the two requirement and the supply. And accordingly, you will be deciding on this particular energy harvesting device and the power management technique. It's a very important thing to consider. I think it will be taken up in your wireless sensor network course if you have. So this is a very important research topic. There are quite a few low power wide area network technologies that have been in use. And as you see, they're basically, we have been talking about that. And this is the one that is the focus of all IoT networks. The idea is that you have to use a low power network, low bandwidth, but it has to be sent over a long range. So this is the difficulty. You have to send small amounts of data because your data rate is limited, but you have to send it with long range and with better battery efficiency. It's not that the battery will drain out. These are the three things that has to be put in one. So long range means you may have to send to 10 kilometers. Okay, 10 kilometers from the gateway. And you will be allowing only 5,000 bits per data. Power consumption is, you should consume less power so that battery goes on for a long time. There have been quite a few LPWAN technologies. As you see, this is its bandwidth requirement. About all of them, bandwidth is really, the range is very high and the bandwidth is low. Look at this range. High range, low bandwidth. Here stands these technologies. There have been a lot of technologies which have evolved over the years, and there are a few of them is like device to device. Directly the device gets connected to the network. In some cases, it uses something called gateway, which is like a repeater, because in many times the device does not have sufficient power to directly send it to the network. So this network is that LPWAN. Normally it doesn't have that power, so it uses an intermediate gateway to send it. And as you see, one of the very commonly used LPWAN technology is LoRa. And this is the LoRaWAN that is used today that facilitates both low power and high range communication. So we don't have scope to discuss in details about this technology, each one of them extensively. So I'll just introduce you to this particular LoRaWAN technique. For more details about that, you can always look up to the internet or the textbook. You'll find details about it. So with this, I finish today's lecture, and this brings us to our completion of the discussion on the different communication technologies, specifically targeting the infrastructure protocols and the service protocols. We saw different kind of low power technologies. We saw how mobiles can be used. And in the next lecture, we'll be focusing on application layer protocols, where we'll talk about MQTT, constraint application protocols, and the rest. So that's all for today.